Okay, welcome everybody. I'd really like to start this with a little prayer to the demo gods, but I don't know which language they speak, because I'll go to do a lot of things live, and with internet stuff and so on. Let's just hope that everything works all fine. All right, so welcome to the session about Kubernetes. This is intended as an introduction to Kubernetes, if you haven't used it before. If you tried it before, then you probably can ask some questions and I can try to answer them. Did anyone actually look into Kubernetes already or started? You did? Just a bit? Okay. Looks like the right audience then. And who has some experience with Docker already? Ha. Who hates Docker? Nobody here? Me, sometimes. Okay, I'm Robert. Most of the time I'm working in an open source project, like for 16, 17 years now. Nowadays it's an open source project called Neos, Neos CMS, a very nice community. And that is basically my background. I'm a PHP developer, but I was always curious about the server side as well, the hosting part. And when I started creating the initial parts of Neos and the Flow framework, I already started creating stuff which nowadays you would call a cloud-native application. So that brings me closer to cloud. And more specifically, why I'm so much into Docker and Kubernetes is that during the last 2.5 years, I've been working on a platform as a service for Neos, which isn't launched publicly yet, but I've been busy working with that a lot, like with microservices and event sourcing and all that stuff in PHP, and also a lot with Kubernetes. So I'm nobody from the Kubernetes core team or something. I'm just a passionate user, but I think that's all fine to share my experience with you. Right, that was the disclaimer. I'm not like one of the official guys. I'm also not affiliated with Google or any other project I'm going to show you. It's just I tried a lot of things and I'll probably recommend you a few things, but that doesn't mean that it's the right thing for everyone, of course. It's just what my experience shows. So how do you deploy PHP applications? So just roughly, who does mostly rely on manual steps or scripts or FTP, SSH, something like that? Yeah. And who automated that in kind of form of Jenkins, GitLab, CI, whatnot? Oh, okay. Cool. Right. So because containers, I don't know, I won't talk too much about containers because you all know Docker, right? But I think Docker is not just some way to have some lightweight virtualization, but the really cool thing about Docker is that we kind of reached a standard for containers, container images, how to run them, how to stop them, how to monitor the basic metrics like RAM usage, CPU, and so on. And that is really what makes Docker at the moment, or some of the few other container frameworks, very interesting. And of course, containers are much easier to ship than any non-standardized format. And you could, for example, use some other package manager, like Debian or whatever, to ship your application. But that lacks the dynamic part, like, for example, telling something about the resource consumption and so on. So it's just a package. And Docker is basically like a container which has its own electricity and air condition and GPS system and so on, So deploying applications with something like Kubernetes is really interesting and awesome. So just wanted to make that clear that don't see Docker as a virtualization technology. It is more lightweight than like a virtual machine, but it can do much more awesome stuff. Okay, so it's not always easy to deal with containers. Who's using Docker in production? Okay, who lost data? Or so ISIS at least. You know that it is or was at least a very bumpy ride, and I don't know what the future will bring. It's still not. I'm still not confident that Docker will be there in 5 years from now. Maybe it is, but maybe it isn't. But I think it's not so important, actually, because fortunately the whole community reached a consensus on let's abstract that container technology and build something more important on top of it. So if for some reason Docker should go away at some point, that doesn't really matter, because the movement about containers and orchestration is so strong already that we could just use a different container technology. But to be honest, it's not so easy to find a reliable production environment for running Docker and so on. You still have to know much about which Linux kernel patches do you need to have applied and so on. So, but I'll talk about the challenges a bit later. So orchestration, what is that actually? Just imagine all your Docker containers are parts of an orchestra, so that means you don't tell them exactly what they need to do. They can do that on their own, but there needs to be someone who says, okay, now it's your part, and now you please be a bit quieter, and so on. So someone who oversees that everything plays nicely together. And that is basically the idea of an orchestrator. And more specifically, when you look at containers, you don't need an orchestrator if you want to run one container on one machine. That really doesn't make sense. It's also not efficient, right? Because in order to run Kubernetes, you already need at least 5 servers only for Kubernetes. So it doesn't make sense if you only run one container, right? If you have 2 servers, it also probably doesn't make sense, because then you can run a for loop with bash scripts and still get the same nice results. But it gets very interesting if you do more than 2 servers. And then there's no difference if you run your applications on 3 servers or on 5,000. So an orchestrator actually decides where to put a container. If the machine goes away, just dies or something, it will relocate the container to some other machine. It will make sure that traffic is going to the right containers, and all that stuff is done by an orchestration. So something about Kubernetes specifically. So Google is like other providers, of course, is providing something they call Google Compute Engine. You know that from Amazon or some other providers. So you basically can rent a virtual machine, and you pay by the minute, and you get a whole machine with 1 CPU or 5 or 10 or whatever. And so they launched that, and then they looked at how these virtual machines were used and said, like, that is completely stupid. They are idling a lot. I mean, yes, we do earn money with it, but it just doesn't make sense. You know, like you have these 15% CPU usage. And we internally use a container system for 15 years, so we should actually provide container technology to those who currently rent our virtual machines. And that is actually a bit, that is a slide from last year, and I wondered if I should still keep it. There's something called Artisanal Infrastructure, or so that means, yeah, that's the nicer name. Previously it was called the pets versus cattle paradigm. Anyone heard of that? Cats and pets and cattle. So imagine your server is like a pet, right? So it becomes part of your family, you give it a nice name, you care for it, you are worried when it feels sick, and you get up at night when it screams, and so on. That's a pet, right? And the idea about cattle servers is you just buy 500 of them, and if some of them dies, you just buy some new. They only have numbers, right? And yeah, I said I wondered if I should still have that slide. I mean, it explains the idea, and actually there was a concept in Kubernetes which was called pet set, just because of this paradigm. And I think that was the biggest discussion and biggest backwards incompatible change they did during a beta phase. They completely removed that name again just because of ethical constraints and concerns. So currently it's called stateless set. Yeah, I like that quote from Werner Vogels from Amazon. So I've hugged servers enough in my life, and they do not hug you back. They hate you. So nowadays, there's no sense in caring for a specific server. You know, running it, installing an operating system on it, and so on. It just doesn't make sense anymore. So the system Google has internally is called Bork, and they introduced it like 17 years ago. And you need to imagine that everything Google is doing internally, be it like Google Search, Google Mail, or even the Google Compute Engine where they provide servers to you, is based on containers in Bork. So that is kind of a planetary scale cluster for containers. And it changed the way people are developing and working with applications a lot, as you can imagine, because previously you would develop something and try to specify what it needs and then talk to operations. And I mean, we have customers who don't have just one operations department, but like 7. One is specifically responsible for databases, one for firewall, and so on. So you talk to all these departments and then agree on how you can deploy that software and so on. And when you use containers, what you do is, with some configuration, you specify, I think that this application needs 8 CPUs and that amount of RAM, and for example, it likes to be on a server which has a strong GPU, yeah? Or I need a very fast hard disk, or I don't really need a very fast hard disk. You just specify that in configuration and put it into the cluster, and the orchestrator will make sure that it runs somewhere. It doesn't really matter where. And if that feels awkward to you, like, where is my application actually running on which server? I mean, when you run a process on your computer, you have multiple cores, of course. Does it really matter on which core your process is running? You don't decide that, right? There's software which does that for you. And that's just the same with containers. It really doesn't matter where it is. And by that, you can use your whole infrastructure much more efficiently, because you don't need servers for one specific application and servers for production, for testing, for staging. You don't need to isolate all that, because it can run all in the same infrastructure. And in fact, when Google runs tests, they have different classes of tests, how big these tests are. They actually run in the same infrastructure, like the live production applications. And the orchestrator will make sure that they are nicely isolated and get the right resources. Right, so they had Bork, and Omega is kind of the successor of it. So, but then some of the developers came to Urs Hölzle, the vice president of infrastructure, and asked him, how about we just take these ideas and open source that? Wouldn't that be cool? And I mean, you can imagine that this is really part of the one of the secrets of Google, how they run their infrastructure. and also to competing with companies like Amazon and so on. But they actually convinced him, and so they didn't open source Bork, fortunately, because as you can imagine, it was a software which grew over 15 years and so on. But what they did was some of the very developers who created Bork and some others as well just took all the concepts and the lessons learned and created a whole new open source project on it. And that is Kubernetes. It is not owned by Google anymore. So nowadays, Kubernetes belongs to the Cloud Native Computing Foundation, which is part of the Linux Foundation. And there are lots of companies involved. It is the most active open source project on GitHub, actually. And I must say, as a developer, I mean, I'm really not into Go and everything, unfortunately. But just from using it, from seeing the API, it's just a beautiful piece of software. It's like the wisdom of the people appears in what you see there. And every time they ship a new feature, for me, it's like Christmas. Anyway, so there are, of course, alternatives. There are other systems, Mesos and Docker Swarm, for example. But they have really a different approach. They concentrate much more on the infrastructure. Kubernetes is really a special thing, and I think it's safe to say that Kubernetes will be the thing to stay, really. As I said 2 days ago, and that's not because I created that sentence, but I think that Kubernetes will be, like for cloud hosting, what Linux is for servers now. So it's a really cool thing. Okay, so that wasn't very practical. I promised that I would be practical. Your application runs in a cluster, and the cluster consists of multiple machines which need an operating system, but that operating system doesn't need to do very much. In fact, it would be good if it doesn't do anything at all besides running Docker, right? And that is how most clusters are used. You can use something like CoreOS or some specialized operating system like Rancher OS or whatever. For example, Google also introduced their own operating system for running their managed clusters. The idea is just run Docker and Kubernetes, and that's it. Okay. Besides this orchestration functionality, Kubernetes also does a few more things which are really nice, and that is way not complete of this list, of course. But it groups your containers. So probably you know that from Docker Compose, where you group containers into one thing. That is called a pod in Kubernetes, that group. But it also does load balancing. So any machine in Docker, in Kubernetes, can receive traffic and route it to the right machine where your container needs to handle it. And it is configurable. It can have something like session affinity and lots of things. So there's a built-in load balancer. It is auto-healing, as I said, so it's constantly looking at your containers and metrics and so on. It will restart containers. You can actually communicate with Kubernetes by probes, for example. You say, my application tells Kubernetes when it's ready to receive traffic. There's a readiness probe for that. Or my application has some health indicator, a liveness probe, where your application tells, like, okay, I think I'm going to die now. Just don't get me more traffic. And for sure, scaling is also very sophisticated. You have automatically horizontal scaling for containers depending on metrics you provide, and lots of cool things. So the backbone of all it is basically two networks, and that is of course software-driven networks. So the internet is connected to your network somehow, and will be able to access the different machines, which are called nodes, through some overlay network. And then there's some internal service network, which is a completely different network, isolated network, where these machines can communicate with each other and with a Kubernetes master server. So the Cubemaster is basically provides a REST API to allow you to launch containers, configure everything. That can be clustered, of course, as well. And well, there are lots of details how to run that, but it's basically the API of Kubernetes, and the nodes are called minions, right? They just do the work, and you can have lots of them, thousands of them. Okay, so I created a little hello world example for you in PHP to see how that really works. Oh, and by the way, I measured the time, so I think this is now the time where I actually need to start a cluster, because I haven't prepared any cluster yet. Let's see, Cloud, container, clusters, create, IPC 2017. Let's say we start with 2 machines, okay? Can you guys read that from behind? Yeah, fine. Okay, it's creating a cluster now. Very nice. I hope it's finished in time. Okay, you have your PHP application, and you have some, which is in one container probably, right? So like a data container or so. And then you have further containers based on images for something like Nginx and PHP FPM. And then you group that into one pod. And you can do the same with Docker Compose, of course, for development. And that is your application. And then you define that whole pod can be replicated and receives traffic on a certain port, like port 80 or something, right? So for your application, you can just define, I start with 1 replica of my pod, or I need 3 or 5, or I change it along the way. And then traffic is routed to each of your pods. These pods, within one pod, you have one shared network and shared volumes. So that means any container within a pod can reach any other pod's network through localhost. So if you put Nginx and PHP FPM into one pod, Nginx can just reach PHP FPM directly. And it's not reachable from outside. And then you can define that you want to expose a certain port to your overlay network, like Nginx in this case. So you wouldn't expose PHP FPM, but Nginx in this case, right? And one thing they introduced, which they didn't have in Bork, which is very powerful, are labels. So each pod, and basically almost every other thing in Kubernetes, can have multiple labels. You give it a key and a value, and then you can do selections. You can say, give me all pods where the label app is nails.io and where the label stage is production. And then you can filter by it and run operations on it. So that is a very basic but very powerful feature. And this whole thing can be called something like a replica set. So it says, okay, we have 2 replicas here of pods and with a certain label. And they form a logical group because they share the same label selector, right? So I call this my, so imagine there would be another label production. I would have one replica set for production and another for staging, and the difference is just that the pods have different labels. But I can address them differently. Now, in order to launch all that, I can theoretically just run a pod, but then I'm responsible for stopping it and so on. What I really want is some mechanism in Kubernetes to take care for me to that amount of replica that amount of pods actually is running. So when, as I said, when one machine dies, then the mechanism called Replica Set or Replication Controller is another feature. We'll always compare the amount of running pods against the amount of desired pods, and we'll fix it. If there are too many, it will kill some. If there are too few, it will start some. By the way, anyone has a question? I saw some questionable faces or tired faces. Anyway, if you have some, you are allowed to just ask right away. So, if you want to deploy from one version to another version, there's a really nice mechanism for that, which allows you to do rolling updates. So imagine you have your application running with 2 pods in parallel, so you automatically have load balancing and failover and so on. Actually, you can even tell Kubernetes to put these pods on different machines, if possible. So there's something called some affinity mechanisms where you say, please, if possible, try to distribute it across availability zones, or don't put them on the same machine, or things like that. So that gives you stability. And if you want to deploy version 1.1, then you just change the deployment resource object, kind of, and Kubernetes will not just stop everything and start everything, but will create a new pod of the new version, and when that is running and the readiness probe is ready and so on, will stop one of the old pods. And then you have basically 2 versions running at the same time. Yeah? Imagine you have 10 or 50 replicas running, then it will gradually transition from the old version to the new version and direct traffic to it. Of course, your application should be able to deal with that. But there are some rather easy strategies to do that, and if your application can actually handle that, it's just beautiful. Nobody will notice that you're rolling out a new update. You can also stop it in the middle, depending. So, for example, when you see, oh, my purchases on my shop are going down by 50%, then you can stop your rolling deployment and see, or actually roll back and see if it gets better and so on. You can script all that. Okay, so this up here is an incredible Docker image I created. It copies the index PHP into some directory and then runs the internal PHP web server to serve that. And the index PHP will just display its version number and the host name where it is hosted. And then the configuration for Kubernetes, there are 2 different versions I'm going to show you. One is called a Replication Controller, and the second is called a deployment. So deployment is actually what you want to use in the future. Replication Controller is still valid, but it's the older concept. So this is a Replication Controller. It basically says, okay, up here, there's a specification which says I want 1 replica of the container of the containers I'm going to explain you. And in order to check if one container is running, I need a selector which matches the labels of the pod which is running. So imagine there's a search query running all the time with this selector, and if there are pods in the result list, then everything is fine. So these 2 must match, the selector and the labels. And it starts, of course, with 0 pods. And when it sees, oh, there are 0 pods, I need to create some. And for that, it needs a template. And that's what you see in the second part. Here's a template how to create a new pod of what I want to have. First of all, the labels, and then comes the actual specification of which containers that pod should consist. Like, I need an Nginx, PHP FPM, and my application. of course, this is a very simple one. The specification just says, I need one container running on this image. Okay, it slept. It needs some coffee. You feed this one with coffee. So now you have that pod running, but how can you actually access it from the outside? Well, for that you use something called a service. A service is something which has an IP address, a stable IP address. No matter if you, I mean, a pod also has an internal IP address, but that changes every time you start a new pod and stop a pod. You get a different IP address internally. But a service has a stable IP address and also a stable DNS name, because Kubernetes provides you with a DNS server internally, and you can just use the name of the service to reach, to get some traffic to it. And this service here defines that it has one port 80, which is targeted to the port 8080 in the container. And the connection between the service and the pod is again done through selectors, right? So it's a really loose coupling. You have the service there, and that can live without pods and so on. It will just not route any traffic as long as there are no pods. But if any pods are matching the selector, it will direct traffic to it. And that can be TCP or UDP for all kinds of purposes. And this here type load balancer is a nice thing. If you have a certain cloud provider, like for example Google or AWS, this means, oh, by the way, could you please create me some external IP address and configure the firewall that this service is reachable from the internet? That's just this line, type load balancer, please. Okay, finally. Let's see if there's a cluster waiting for us. Yeah, there it is. Oh, and there are updates for my tool. There haven't been 30 minutes ago. Okay, so we have a cluster running now with 2 nodes. So what I'm doing first now is I start a little dashboard. Nice thing is a Kubernetes cluster already comes with a little dashboard where you can see which nodes exist, which pods, and so on. So I'll just do that here. There's a command line tool called kubectl, which allows you to run all kinds of commands for the API. Very convenient and nicely done. So I say kubectl. No, first I need to get the credentials. gcloud container. What was it? Like this. So kubectl proxy on port 808099, and now let's see, localhost 808099. There is internet, fortunately. So this is the little dashboard, and you can see that we now have 2 nodes running, and they already consume some CPU because the dashboard is running there and some monitoring is automatically running there. But here this tab workload says there's no container running, and the services tab says there's just one service running for Kubernetes itself. Okay, so that is running. And now the files I've shown you, I have the actual files, so let me do that this way. The replication controller, for example, which I've shown you earlier, I'll just apply that to our API server. So okay, let's see. First of all, there should be a replication controller, right? There is one. And that replication controller is going to create a pod. The current status is container creating. So, and I can see details of it, but currently it's not running. So I can actually ask the command line tool to show me events happening there. There you see, for example, events like, okay, the node is now running and so on. That is all from the startup. And then you can also see, hopefully, then it's pulling the image and so on. You see the events here. And then it's hopefully running. Let's see, is it running? It's running. And you can look at the logs, but there are no logs yet. So nice, there's a container running, but we can't access it yet. So for that, I create a service, as I said. So that service has now been created. Let's take a look. So the service here shows me all pods which match the selector defined in the service. So, and that is called a service endpoint, which means, okay, if I would ask that service now with the internal IP address 1051.243.193 on port 80, it will actually get that traffic to my container which is running, because it matches here. What it does now is also acquire some external IP address so I can actually test it. Before we have that, we can already access the pod by using a nice command called port forward. First of all, I need to get the pod name, which is this one here. And then I can say, okay, please forward the port of that pod. And so I say 8090, that will be my machine here, to the container port 8080. So it's now doing that. So when I access port 8090, I see my incredible index PHP now. And just think about that for a second. You have a cluster with hundreds of nodes and whatever, and if you only know the pod name, you can actually forward that traffic to your machine through a secure channel without having to, actually log in somewhere or so. So this is, this is a really nice way to debug things. I think. Probably it's not allowed or whatever, but it's really nice. In practice, it pays off. Okay, let's stop that again. I'll just delete this replication controller. Goodbye. Okay. So, and obviously this is now gone here. And now the service will tell me okay, there's still, the pod is still there, but it will be cleaned up in a second. And when that is gone, the service won't be able to provide any traffic to it anymore. See, is it gone? Cleaning up takes a bit sometimes. So what I really want to show you now is the deployment. Let's take a look at the deployment again. Okay. So let's start this deployment. Let's say we want 15 replicas of this pod, okay? And there are nice things you can tell about when it will deploy a new version, what strategy it should do, create everything from scratch again, or in this case we want a rolling update and we want to make sure that, let's say, there can be 3 more than the 15 replicas, but at maximum 3 pods can be unavailable at a given time. So that's the strategy you set. And what you see down here is an example of how much resources will that container need, that part need, actually. You can say, I think, also by measuring, it needs 6 MB and basically no CPU. And that is very important for Kubernetes to calculate on which node does that part fit nicely. That is a soft limit, and then you could give it a hard limit and say, okay, when it goes beyond 50 MB of RAM, kill it. It will kill the process and restart the container. And the same for CPU, it will throttle the speed of the container. So let's run that. Oops. And see what happens. We have a new deployment here. A new deployment creates a new replica set. So that's the intermediate stuff in there. And you see 2 of them are already running. I reloaded. Almost all are already running after 18 seconds. And, yeah, first, now we need the IP address of the service. You see now it has some external IP address. Try that if you don't believe me. And when I reload here, what you see is that different hosts are responding. So you see now that load balancing is in effect, and it will distribute the traffic to different containers. You could even tell it to have session affinity so that depending on your cookies, you will end up, or IP address actually, you will end up on the same container if possible. And now let's upgrade to a new version. And the difference to the previous file is just that it's using a different Docker image, right? A different Docker image version. So let's see. Yeah. So I knew it because I I changed the original file. I need to do that for the version 2 as well. So don't mess the files before the demo. So now it should go, and it's very fast. So let's see. Oh, it's already version 2. Too bad. Maybe I need to roll back. It's too fast. Maybe I put it on the side here and try version 1 again. Version 2, version 2, version 2, version 2, version 2. Version 1, 2, 1, 2, 1, 2. 1 is getting more. So, I mean, that is the idea, right? So it's in the end, it's only 1, and then you rolled out your application. So, yeah, just quickly about the challenges. Cluster upgrades, you need to take care of that. There are nice commands for it now in the meantime, something like kubectl drain, which will move out all containers from a given node, and then you can start new nodes and so on. But if you don't have at least 2 replicas running, you will have some downtime when the container is relocated, of course. Which brings me to application fitness. I mean, if you just put a WordPress on Kubernetes, which needs a persistent file system, yeah, how do you do that, right? Because usually these persistent file systems can be only connected to one node, at least with the major providers we have. So that means you actually need to stop the container, put it on a different node, and then reattach the hard drive if you want. So, but if you have a more modern application, like 12-factor application is the deal, then it works very nicely. And of course, with microservices, it's ideal. And storage is still the problem, of course. Kubernetes could mount read-write storage to multiple containers at the same time, but the cloud providers cannot do that yet. So that you have to keep in mind. If you need a persistent file system, like, I don't know, for database, for example, you will have some downtime when you relocate it. But you can do read replicas, for example, or master-slave replication and so on. You need to take care of your image build process, right? Right now you can even get that from major cloud providers. For example, Google offers that for free, basically. You can use GitLab CI for that. I really recommend it. But the whole deal about monitoring and debugging and so on will be very different from what you probably know from regular servers. So you need new solutions for that. I'm not such a big fan of New Relic because it's so expensive. Datadog is not free, but it's pretty specialized on and tailored to Kubernetes. I think it's for free if you have 5 machines, so I can definitely recommend it for that purpose. They have a very intensive sales process. They will call you lots of times, like New Relic and so on. They will send you T-shirts and helicopters and whatnot. So, but you're used to that, right? So if you want to get started, basically just go to Kubernetes.io. There are some really nice talks. If you watch for some guy, just you will stumble over him anyway. Kelsey Hightower, that is kind of the most famous and humble and friendly ghost of the Kubernetes universe. Very nice talks. And there's even something called Minikube, which is all right for testing that locally. It's basically in a virtual machine running a Kubernetes cluster on your machine. Right, so, my personal recommendation is currently, as you've seen, Google Container Engine, because you don't need to take care of the management of Cubemaster and so on yourself. They'll just do that, and it runs flawlessly for me for over 1.5 years now, so I never had really any big problems. So it's very exciting, I can say, but don't rush it. Think about why you want that and need that, but I think it's definitely worth looking at it. And by the way, Neos is really nicely suited for cloud environments, right? So thank you so far.